The objective for this session is to talk about the ISG ENI, which is an ISG that's been set up about 11 months ago. So it's partway through its progress. We've come to a position where the ISG is reaching a stage where a number of documents have been sent for approval to be published. And so, okay. I'm Raymond Forbes. I'm the chairman of the ISG. Although it says I'm Huawei Technologies, I'm a consultant for Huawei Technologies at the moment, so I don't view myself as a Huawei employee, but okay. So going down the list, Haining Wang is the vice chairman from China Telecom. Now she's been very active in providing use cases. Fred Fuselier is from Verizon, and we've had quite a few presentations this week from Verizon, so we've heard quite a bit about Verizon's goals are. Ye Wang is from Samsung, who's sitting in the front. You'll hear from her later. And we have an ETSI support from, I can never pronounce her name, Sylvia Korniskaya. I'm sure someone from ETSI can pronounce it better. Okay. That wasn't from ETSI, but yeah, you're right. If you can pronounce the words correctly in Polish, I think you can get it right. Cool. Yeah. Okay, thank you. I'm not going to attempt to repeat it. I can pronounce her first name. And Dr. Shushen Liu is, I call him Will, he's really working for Huawei Technologies. So that's the management team as we are today. And, okay, so that's the group. Now, the slides, basically I will give an introduction, and I may not keep exactly to the previous time, but there will be some time for questions toward the end. So what I'm attempting to do is I will give an outline to the group, and then I will give a bit more detail as to what the goals and objectives of this group is. And I think the group is complementary to ZSM, the group which Dr. Klaus Martini was talking about earlier in the summit. So it's not, we're not competing, we're working alongside each other. And the aim is to make us more efficiently work alongside each other. And then Ye Wang will give some of the information on the use cases and requirements and a bit on the terminology. Then I'll give a bit more on the architecture, which we have just started, and a bit on the proof of concepts, which we are also starting as well. Okay. So the background and vision of the group is that we wanted to use artificial intelligence to assist the operations of the network, to assist the service deployment in the network. And we're not actually doing zero-touch management as such, but we will employ techniques which could be used in zero-touch to work towards making or keeping the efficiency of the network running. The aim, I say keeping the efficiency of the network running, China Telecom is one of the use cases. They've said that with the deployment of SDN and NFV functionality across their network, the management of the functions in the network will probably become 5 or 10 times more complicated. So if that happens, they will be struggling to simply maintain where they are. We would all like to reduce the OPEX. And that's the goal, is to have reduced OPEX. So that's the vision of the group, is to reduce the OPEX, is to go forward and to define interfaces if they are needed, not to define interfaces just for the fun of new standards, because although we are all standards engineers, we don't simply want to create things for the fun of it. We want to reuse the interfaces. So that's the introduction to ENI on network intelligence. So we want to have intelligence across the network, not intelligence just in one set of NFV functions, VNFs. And we want to use the structure of VNF or NFV to collect information from around the network, whether that's legacy systems or whether that's SDN systems, through the controllers and up into the network controllers. So the activities were started well, there was initial activity in 2016. The real activity of the ISG was started in April 2017, which we're 11 months into. So other related STOs, Well, we are actually discussing with most of the SDOs that have been talking here, all the SDOs that have been talking here, and there is a slide later on that we'll get to on that. But TMF and MEF, we have we don't have a close liaison yet with MEF, but we have quite a good relationship on reusing information from MEF. And so in our documentation, and our rapporteur, one of our rapporteurs is the chairman of the MEF LSO architecture group. So there is quite a good working relationship between the data of MEF, and we have quite a good relationship on reusing information from TMF as well. So these are the major industry consortia we see here. Oh, press the wrong button. Over here, you can see these consortia over here. We have 6 work items. At the current time, we have ENI 001, use cases 002, requirement 003, which is a report on context-aware policy modeling, and 004, which is a report on terminology. We have 005 on system architecture, which is led by Verizon and John Strassner from Huawei. And we've just started, and it's in a fairly complete state, because it's a framework document on proof of concept. POC is proof of concept. And that is along the lines of what Klaus Martini started in his group, and Diego. But we've all based our work on what the NFV group did in Diego Lopez's group. So that's called 006. And that's been, the rapporteur for that is a guy called Luca Passando from Telecom Italia Mobile. And the co-rapporteur is Essa Mustafa from Vodafone. So what's the goals of this group? The goal is to improve business efficiency, reduce OPEX, or maintain OPEX as the network becomes more complicated, have increased profit, and introduce the main things we foresee in the near future of the 5G goals and the IoT massive goals, the massive IoT deployment that we are all expecting. I mean, I used to work in 1M2M, so I'm aware of the IoT issues. We want to improve or give better customer experience. The customers always want better experience in reality, but we want to make it appear better. People expect every upgrade to make a slightly better service, although not to simply slow things down like the upgrades used to do on my computers when they were less powerful. But the upgrades which I get at the moment seem to improve the security. And we want to increase the value for money. So if I have time to talk about the network technology evaluation, as the networks are changing rapidly, we're deploying network intelligence within the network and across the network. In network management and operation, and network intelligence is being deployed to replace or to enhance or to assist human decisions. Complex situations for management always need, you can't simply replace a complex system with a simple system, but you can hide the complexity in the complexity. So artificial intelligence should help the human being. Artificial intelligence shouldn't be a robot taking over the network and running away with it. I mean, that's the last thing you want. But robot taking over the network, I suppose maybe in the distant future of autonomic networks. But, we need to get to that position. And the main goal of this group is to work on the AI deployment. So we have step 1, where we have the telecom hardware, which was here, which was changed to common off-the-shelf platforms, and there was software platforms put on top of it. That is put in very simply what SDN and FE is, in about 4 words. The goal is to use very common platforms and to use software on top, inside the platforms. It's hard to draw boxes that have software in them, because you have to draw boxes in somewhere. You can't draw software on a bit of paper easily. But you still have a manual operations level. Management is not necessarily the best word, but this is the whole issue of the network operation. So there's nothing changed at this higher level. So the goal of ENI is to use artificial intelligence to improve the operations, to allow the network to be, or the network managers to be assisted, the network operation to be assisted, the network service deployment to be assisted. So the goals of this group is to improve the operator experience adding closed-loop artificial intelligence mechanisms based on context-aware, metadata-driven policies. Now, there's quite a lot in those few words. Improving the operator experience, I suppose, is understandable. Adding closed-loop artificial intelligence. What is a closed-loop artificial intelligence mechanism? There may be loops within loops. There may be reconfiguration of certain loops chosen in certain contexts. There may be loops which are redundant at certain times when the context or the policies say not to use that loop. So we may end up having closed loops which work all the time, and there may be loops within those closed loops which are invoking certain policies. We specify a set of use cases, and our goal is to produce an architecture which will enable vendors to sell software which hopefully is completely deployed across the network. So we're not aiming to sell boxes, we're aiming to sell artificial intelligence tools into the network to deploy them where people want to put them. The aim is to assist decision-making systems and to adjust the services and resources. Today we have 28 members, or depends how you count them, there are 30 members on the ETSI website, but the management team I've talked about, the other members, Avida Optical Networking is on the list, Amdocs, Aria Networks, CADSO Communications. I've taken off communications, it was too long to write in this box. CATR, which is the Chinese government, Changhua Telecom, which is Taiwan Telecom, it's the telecoms operator in Taiwan. Convida Wireless, which is an amalgamation of Interdigital and Sony. ETRI, which is an institute, a research institute for the South Korean government. Intel, I think you've heard of Intel. Medocom, which is a kind of small company. Portugal Telecom, Telefonica. And Telefonica joined on Friday or Monday, depending how you count that. So they're quite new. I mean, Diego Lopez sent me an email. Yeah. Yeah, correct, fine. Okay. Diego said exactly what I was thinking. I recognize his voice. I can't see him. There's light in my face. That's why I can't see. Okay. Okay. TIM, Telecom Italia want to be known as TIM in future. University of Luxembourg, University of Surrey, Vodafone. Vodafone joined a few weeks ago. Wings, 5G, MC5G Limited, Xilinx and ZTE. And Layer 123, Rugi Network. SK Telecom is the South Korean telecom, the second operator. The Korea Telecom is the main operator. And Hong Kong University of Science and Technology. Okay, they're the logos. So, I think Telefonica's on the top, you can see. Okay. I think all the rest are there. Okay. I mean, most of those are the same logos that are in the other groups as well, so I'm not suggesting. There's no reason they would contribute to both groups to make the groups do similar things. We want minimal overlap to maintain efficient communication and efficient interworking. We want maximal separation to maintain a degree of complementarity. We're doing complementarity in the mathematical sense, and then we're doing adding on to each other's things. Okay. So I've said identify requirements to improve operator experience, which is what we have done, what we will continue to do. Enable intelligence service assurance, that's one of our use cases, but we will talk a bit more about that. Publish a reference architecture, which is what we will do in the next few months. Engage with STOs, which is what we're continually doing. And standardize how the network experience is measured. That is the goal for, I suppose, the second phase and later. Okay. So these are just a flavor of the use cases. There's a network operations set of use cases. There's the orchestration and management, service orchestration and management set of use cases. Network assurance set of use cases, infrastructure management set of use cases. It's not an exact fit because some of the use cases seem to cover several. Policy-driven IP managed networks, radio coverage capacity and optimization. Yu's going to give more lengthy description on what many of these are. You've picked out a number of these, and we're going to talk about them. And there isn't time today to talk about them all, but the document is available to all ETSI members. The document will soon be available to everyone when it's published. The document is available to ISG participants who are non-ETSI members, who like layer 1, 2, 3. Okay. Intelligent service rollout is the issue about rolling out new service across the network. Policy-based network slicing. I mean, we're talking about network slicing about the use of policy and the use of reconfiguration. We're not aiming to define network slicing. We're aiming to define the intelligent configuration of network slicing, the intelligence behind it. And so we're picking out here for IoT security, IoT Internet of Things. Intelligent front hall management and orchestration. Under the service orchestration and management, we have context-aware voice-over LTE, service experience optimization. The voice-over LTE is the voice over the fourth generation network, mobile network. Intelligent network slicing management, that's the management of network slicing, so that may be where the intelligent carrier managed software-defined WAN. We've heard quite a lot about software-defined WAN. We want to look at the intelligence of the carrier management of software-defined WAN. The network assurance, network fault identification and prediction. It's very hard to predict faults, but you need to identify faults as quick as they occur. And you need to have a network which is, as far as possible and as quick as possible, self-healing. Like it can route around the faults. I mean, when I started my career in the 1980s, we started on a system which routed around faults at a very low level in the network. So BT in the UK were buying this thing off us. I was working for Plessy, which no longer exists. So and the system worked, and it was very good, and BT bought it, and it probably is still working today, long after the company is. So, I mean, it wasn't called BT then either, it was called GPO. Assurance of network service requirements, infrastructure management, policy-driven the internet data center traffic steering. They want to steer traffic in the data centers between different computers in the data centers, different parts of the data centers, to get the optimal load across different parts of the data centers. And related to that is the optimization of energy usage using artificial intelligence and handling of peak planned occurrences. Now, not surprisingly, quite a few companies have use cases defined around planning of peak occurrences, planning of optimization. And I mean, there's no need to take a photograph because these slides will be downloadable. But you can take photographs if you want, so I'm not against you doing that. Okay, I can see people raising their cameras. So, I mean, for instance, when you drive around a big city like Beijing, or maybe like, I don't know, Madrid, because I'm not driven around Madrid, but you see lots of traffic direction monitors. The traffic direction monitors need information in near real time. Near real time means like around a second, because if they get the information too soon or too late, you simply move a roadblock from one place to another place. So if you get the information in as quick as you can and link that to the traffic lights, you can spread the traffic out, which is what they want to do. So, okay. Another IoT example is the example of clearly a farmer wants to give the right fertilizer and the right water to different parts of his farm. He doesn't want to give too much fertilizer, which might kill the plants. He doesn't want to give too much water, which might cause flooding. But equally, he doesn't want to give too little because he wants the maximum yield out of his crops, whether he's growing wine or whether he's growing vines for wine, whether he's growing wheat. It's all kind of commodities of crops have similar characteristics. If you give them too much fertilizer or too much water, they will die. If you give them too little, they will die. And yeah, today you can be very efficient with drones to collect the data. So data is very easily put into a system, but you need a very clever system to work out exactly how to water, how to fertilize. Okay, so that if you start to interpolate that towards telecommunications, you can start to understand the kind of problems that will exist. Okay. So this diagram was, in fact, worked on a couple of weeks ago, and the ENI 5 meeting was only 2 weeks ago. So I will discuss more about these pink boxes, these 5 boxes, which are the artificial intelligence system. I'll give a bit of information about what each of these means. This is the traditional ISO layer. It's also the kind of stack that exists in NFV. So the idea is, in this simple high-level diagram, is to show how the interworking is. Now, we haven't yet developed the detailed architecture. We're just trying to develop a high-level framework to talk about the reference points and the functionalities that will go into the more detail of the document. We need to analyze how companies want to make public information that they may want to be developing. And we need to then move on to analyze whether we need interface reference points. We need to develop interfaces, whether we need new APIs or we can reuse existing APIs, so we need to develop new payloads to go over the APIs. The aim is not to develop new APIs if we don't need to. Yeah, okay. So this diagram shows E&I as a big box. Can I get this point? Yeah. It's a big box here, sitting alongside a MAMO system. So the MAMO system was taken from the documents in MAMO, and we show how policy is put down into the OSS and BSS, the orchestration levels in MAMO, and policy is put into and there is data flowing. And so data is reaped from all parts of the network into the ENI system, and data flows back into the orchestrator. So the closed loop is the data being reaped, ENI analyzing the data and feeding back the information. And the management loop on the top about how policy is put down into the systems. Okay. That's at a very high level how the system works. Okay. I don't know if we specified any more details yet. But I want you to specify the details, not me. Okay, this is the same diagram related to the MEF LSO architecture, RA reference architecture. And so this diagram is very similar to the LSO architecture, which was shown by the MEF people, in fact, on Tuesday. And we show some similar arrows as to how we use the blue lines to reap data and the green lines to inject information back in. And in fact, the lower layers of the MEF architecture is untouched, although they may want to reap the data from the interfaces. Okay. So this shows, I suppose, where we are, where we were, the manual control. And we want to take the data and extract information from the data. We want to then move on to calculate knowledge from the data. So we want the automatic automation of services, service distribution and network deployment and management through the integration of network management is all human controlled. So this is where we are currently. We want to move to an adaptive intelligence system, which is somewhere in the middle here, which is where we will be in a year, if not now, in a year or two's time. Now, to move on to actually artificial intelligence wisdom is perhaps the autonomous goal, which I personally believe is not quite here. It's a nice thing to aim at, but I think we need to learn to walk before we can run. No. So we need to build up confidence that the AI is providing the right kind of instructions to people. We need to use the AI to train the network, to learn from the network, and we need to use the ability and the knowledge of the managers who operate the network from day to day at the moment. We don't want to increase the number of people in the workforce. We don't want to increase the number of managers that need to be trained. We want to use the current people and let them retire happily, but let the network continue being run by less and less people in the future. So, again, this is where we are. We started with some brainstorming event in December 16. We've had a launch events, kick-off meetings, and this is roughly where we are now. And so we have a use case document, a requirements document, a context to work, which are all at they've been sent out for remote consensus in the first approval phase. We have a terminology at version 1, which is now stable, and there is a meeting, I think, next week, or the week after next, to work on that and to finish it off. Because I don't think these will make a lot of sense without a terminology. But, I mean, the terminology is very similar to what's used in other groups. The architecture document was started in December, and we have an early draft, which is available to ETSI members and to ISG members. So many of the people, or most of the people in the room can get it. The final drafts are available to most people, or they will be openly available once they're published. The POC framework needs to be available for approval before we can start the POC. That's the reason it's quickly gone from first draft to the report has been sent out by remote consensus to be approved as a final draft. So it's not quite at the same level, although I think the words are the same on this table. It's not quite at the same level yet. Now, when it's approved as ready to be final draft, as chairman, I can send a proof of concept, a request for proof of concepts to people, to the committee, and I hopefully will get some back. We had one available at ENI 5, although the only missing thing was there was no team leader. It was very well worked out apart from that. It's quite, I have a very high hope that we'll get a team leader by a couple of weeks' time. So the aim is to then send this for approval, for remote consensus for publication approval, shortly after the... we can then start a review team. The review team will start as soon as the first proof of concept comes in. Now, the aim of the review team is to review and the review team will be led by myself as chairman of the ISG, and the two people who've deputised have offered volunteer. That is Luca Pasanda from Telecom Italia and Mustafa Essa from Vodafone. And I think that's a good start. There are a few more people who would offer to help. So this is roughly where we are. I think I've said this. Actually, I've talked for far too long. So this is the proof of concept. This is a very useful diagram here because we've the real aim of proof of concept is to prove the concepts that we're developing in the architecture and the use cases and contribute back to the use cases and architecture. The team in the middle is a means to an end. It's a nice flow diagram. And the teams themselves in the blue line are independent of the ISG. They need to contain 1, 2 or more ISG members, otherwise we won't get any contribution. But they may contain as many non-ISG members as they want to. For instance, the one which China Telecom has proposed already has about 10 members, of which I know 2 of them, China Telecom and Huawei, are ETSI members. Some of the others are not ETSI members. Most of the other members are, in fact, 3GPP members. So the interaction with this group is, well, this diagram shows us sitting in the middle, but we've talked to various ETSI groups, which are listed down here. Now, this ETSI groups would appear to come out of the picture, so it's not three-dimensional. But there are various industry groups that we have talked to here. GSMA and BBF we're talking to. IETF and 3GPP we are talking with. ITU, MEF and TMF we're talking with, as I've said already. And ONAP and other organisations we wish to work with. And also OSM. OSM is an ETSI group, so we haven't listed it here, I was told. So this shows some nice pictures of the information we've had. So the initial forum, we had a number of members and non-members who came to the initial forum event. We had another session last year, which was 140 plus participants. It was very well attended, and many people were interested to see what was going on. And we had a workshop in December with SliceNet. Now, SliceNet want to contribute to ETSI, and the main contribution to ENI would be to look at automatic reconfiguration of network slicing. So these are just a summary of the list of other groups that have been created in a similar around the ecosystem. Thank you. Our next meeting is in Turin, and planned at the end of June in Turin. And, well, all ETSI members are welcome to join us. If you don't become members in time, then if you want to just come along and we can give you an invitation to come as a guest for one meeting. If you're a non-ETSI member, well, talk to me. It's the best thing. If you want to join us, you can do the same as Telecom Italia or Vodafone or Telefonica or any of the other people on the list. So at this point, I'd like to hand over to you.